Hi, my name is Marc Tuduri. So today I'm going to talk from PIDs to pods, the life cycle of an eBPF-autoinstrumented application. This is about the challenges that we had to auto-instrument applications in the context of Kubernetes environment. First of all, a bit about me. I work as a software engineer in Grafana Labs in the Beyla project. We're going to talk about this in a moment. I'm a Prometheus contributor and an OpenTelemetry member, and I'm currently based in Berlin. And when I'm not smashing buttons, I also smashing drums, or at least I'm trying. Yeah, a bit the overview what we're going to see today. What is auto-instrumentation with eBPF, and also what is eBPF. Then we're going to talk about the challenges of instrumenting applications in Kubernetes with eBPF. We're going to talk about the journey from a PID to a pod, how we can use Beyla at scale in Kubernetes, and we're just going to review how all of this works in Kubernetes. Okay, so let's assume that we have our own application and we want to see how our application is performing. Typically, we can use what is called the red metrics, which is request per second, error rate, and duration. Or we just want to have traces when our applications are calling different services or different databases. Most of the time, we have to do, and then we're going to send all of this telemetry data to a collector. And for that, most of the time, we need to do automatic manual instrumentation, which means that we have to go to our code and we have to add specific lines of code or like libraries or framework to do this instrumentation. And depending on the language, you can do this easier than others, and in other more dynamic language, you can use automatic instrumentation using SDKs that they are provided in OpenTelemetry. But this has some challenges. What if our runtime is too old? So maybe we are using a very old version of PHP, and it's simply not possible to use the last fancy SDK of OpenTelemetry, or just using some of the instrumentation framework that is around now is adding too much overhead to our application, or we just have a binary which is very old and we don't want to touch that code, and or simply we have also like a giant code base, and instrumenting everything will require that we have to touch a lot of lines of code. So, or we just want to see what's going on now. We don't want to have to plan work or like for the next quarter or whatnot. We just want to see what's going on right now, because the task of instrumenting our code is going to take a lot of time. Introduce Beyla. Beyla is a project that was born in Grafana Labs after a fork of an OpenTelemetry project, which was automatic instrumentation for Go, and we evolved it to have support for multiple languages. Now we're going to see how it works in a bit, but the idea is that Beyla, it attaches to any running application that you have at the kernel level, and is able to automatically get the red metrics or traces of the running application and sending to either OpenTelemetry collector, Prometheus, or directly to Grafana Cloud. But what is eBPF? Maybe some people here know what is eBPF, but eBPF stands for extended this, but no one uses this because it's confusing. And nowadays It stands for endless bugs, painless fixes. If you think that is not funny, it's because ChatGPT wrote that joke for me. But basically, what eBPF is doing is a virtual machine built into the Linux kernel. It allows you to do some sort of event-driven programming. So basically, you have what is called a probe, and the probe allows you to hook to specific kernel functions. And when this kernel function is triggered, the probe is going to be executed and it's going to do something for you. It requires to know how the memory is laid out, so it's quite low level, and then you have to know how the function call arguments are done and how the local variables and return values are stored. So it's a bit tricky to work with. Let's see a quick example. Imagine that we have sysconnect function as a kernel function, and we have an application here that is gonna require to trigger this kernel function, and we also have a monitor program, and this is what it's gonna do is gonna load the probe into the kernel, and the application is gonna call the sysconnect function. Our probe is gonna be executed. It's gonna do some calculation, and it's gonna generate this data in what is called a eBPF map, and the eBPF map is going to be able to be loaded in the monitor program and read this data for us. So a bit of the pros and cons of eBPF is fast, it's just-in-time compiled, it is safe because all the programs are verified at the load time, so you cannot do like any nasty hacks. It's easy to clean up. Once the monitor is terminated, all the resources are reallocated. And some of the concepts is like hard to debug and write. It depends on the architecture. And depending on the functions of eBPF used, it requires elevated permissions. Okay, now that we understand a bit what eBPF is, let's see our journey of instrumenting Kubernetes applications with this technology. So let's assume that we have this basic idea. We have our application inside of Kubernetes, and we receive traffic to the get users. What Beyla is going to do for us is generate this metric called HTTP request duration, and it's going to enrich with the path and the method, and of course the duration that took to perform that request. This is the architecture of Kubernetes using Beyla. There's two ways. One is using Beyla as a sidecar container, so it's going to be inserted in each pod of the instrumented applications that we want to do, or we can run Beyla as a daemon set. So it's going to be one Beyla instance deployed per node of our cluster, and this change a bit, but if you want to deploy Beyla in a simplified way, you have to do privilege true and host PID true. So what Beyla directly sees, when we use Beyla to instrument processes in our host, for example, without Kubernetes, it can see things like command name, process ID, and host name. But when we are working in Kubernetes, what users need is things like the pod name, the metadata, the node name. Yeah, all the Kubernetes metadata that is required for us to debug like any metric or like any operation that happens in our application. So So okay, now that we know the requirements that Beyla needs for to instrument applications in Kubernetes, let's talk about the journey from the PIDs, which is the low level, to a higher abstraction is a pod. This is what Beyla sees in higher level when instrumenting an application with the eBPF probes. We are able to see application level runtime metrics. It is also able to go to the /proc file system, and in there it can get some metadata of operating system level, and it's also able to access to the Kubernetes API to get metadata from pods. The problem here is that there's no direct mapping between host and PID in Kubernetes metadata. So how do we tackle this problem? Well, it's not easy because depending how you deploy Beyla, like the function of give me the PID is going to give you different results. If you just ask the PID at pod level, it's going to return 1. If you deployed Beyla as a daemon set and host PID true, it's going to return you this PID, and it's not the same PID that is in the kernel. So we have to do something here to match the PIDs. So the PIDs and and when Beyla goes to the proc file system, it's able to through the PID to get the container ID. And luckily in the pods we also have container ID, and there's also this PID namespace, which is the PID that we saw before, which is this local PID namespace, and we have to do some internal like search to match all these PIDs that is actually obtained from eBPF probes. Just to recap the journey of an application trace, there is service request and the probes are triggered and they find all of this information. Then there is the process of PID matching, and we execute the Kubernetes metadata decoration, and finally we are able to generate either metrics and traces and send it to our collectors and our Prometheus instance. Now I want to talk about briefly about how we use Beyla at Kubernetes in Kubernetes at scale. This is an extract of a talk that we did in the KubeCon. So if you want to know more about, you can watch the video. But how the Kubernetes metadata decoration works is that each Beyla pod or daemon set has to subscribe to the Kubernetes API through the informers method, and this works great in smaller clusters, and that's probably what you should do, like have a small clusters. But we have clusters of 1,000 nodes, and this is what happened when we deployed Beyla there. And yeah, basically we DDoS Google Cloud, and we killed the cluster, so we had to roll back. And so how do we fix this? There are different solutions discussed, but we came up with to use a centralized cache, which works as basically like we have a Kubernetes cache service, which is doing this which is enriching all the caches with metadatas, and the Grafana Beyla just need to go to the services and to the Kubernetes cache service and fetch this data without having to each individual instance to go to all the Kubernetes API. But let's do a quick preview of how it looks. This is a basic config. We are telling that we want to use Prometheus and we want to instrument all the deployments and daemon sets of the namespace default. There is in what is it called, OpenTelemetry demo, which is an example of a microservice architecture where there are many services calling each other, and OpenTelemetry provides this to showcase that OpenTelemetry is capable to instrument different services in different languages, in different protocols. So what we did is strip all the instrumentation, and we deploy Beyla in a Kubernetes cluster, and this is what we see. So we are able to instrument all of the applications that they are running in the cluster, and for an individual service, we are able to see, like what I said before, the red metrics, and you can even see, like, per individual service, like the latency, and we can also even see the dependencies between services. And this dependency between services is also easier to see in this service graph. And so we basically see the connectivity between services, and we can also see how each service contributes to the latency of other services. And last, I want to mention that for us, like open source is a core principle. So we brought back, we donated back Beyla to the OpenTelemetry project, and we successfully did. And now we are under the project OpenTelemetry eBPF instrumentation. So yeah, I invite you to come here and contribute and take a look at what's going on. And yeah, that's all. So if you have any questions.
You've mentioned multiple times that you are able to collect metrics and traces. Is there an option to collect logs?
There is a question that Beyla currently works with metrics and traces. And the question if it works with logs. So the answer is no for now, but it's not the first person that asked for that, so we're gonna look into that at some point. And I think it's feasible, but it's not straightforward. Yeah.
What is the performance impact? How do you measure the actual time take to measure?
Yeah. So there is a question about the performance of Beyla. I think I forgot to mention one of the benefits of using Beyla instead of SDK for instrumentation is that it's much faster, because the like executing probes they're done in the kernel level, and it's quite fast. And we also did some performance tests and some analysis, and they're in the Grafana Beyla documentation are available. And it's the performance, the overhead is very minimum.
What about the trace IDs? Basically, when you use microservices talking to each other in HTTP, you propagate the trace ID together, usually. But for example, when you use service bus, if you would like to see the dependency between the services over the service bus, you cannot do that in all the documentation.
Sorry, can you repeat?
Basically, when you use some middleman like Cube or something like that, you propagate the trace ID,
Mm-hmm.
dependency between the applications.
Yeah.
Can you do that with Beyla or?
Yeah, so the question is if it's possible to see the dependency between services.
Yes, but when you use something like queue, like queue or
Okay. So the question is if it's possible to see the dependencies between services when you are using other storage system like RabbitMQ or yeah. So for RabbitMQ specifically, no, but we have instrumented for other storage system like Kafka or Redis. So it works on the way at the level of client calls. So means that if your application is doing a Redis operation, we're able to track this Redis operation. But what happened inside of Redis, that's another world. Yeah.
You mentioned on the slide that you have this architecture dependent. What does that mean? Because as far as I know, it compiles, right? So it should not be architecture dependent. What do you mean?
Yeah, it means that. Sorry. Yeah. The question is if. The question is that I mentioned that Beyla is architecture dependent, and the question is, what does it mean? So most of the time it works in different architectures, but like it's not the same like in different kernel levels, or if you are using ARM or AMD and all of this stuff. It has some nuances, and the APIs of eBPF that they are provided, they are already allowing you to program without having to think about these things. But for example, in Windows, still the support is not completely done, so it's also a bit, yeah. Thank you.